In the previous video, we found these formulas for the three components of the velocity, u, v, w. These are the three components which are expressed in terms of this function that I called f. Now, you can see that there are some derivatives to calculate inside this formula. So, in order to be able to write down the final expressions, we need to calculate some derivatives. For example, we need to find the second derivative of rho with respect to xi squared. So we have d xi of the derivative of rho with respect to xi, but the derivative of rho with respect to xi is xi over rho. And the derivative of this is simply 1 over rho minus xi squared over rho cubed. And from here we can also calculate the third derivative of rho with respect to xi. Why do we need the third? Well, because you can see here that there is the second derivative, but when we substitute this expression here, we have the derivative of f with respect to xi. So there appears the third derivative of rho with respect to xi. So this is equal to the derivative of the second derivative, and therefore we can write minus 1 over rho squared times xi over rho minus 2 xi over rho cubed plus 3 xi squared over rho to the fourth times xi over rho, and this is equal to 3 xi cubed over rho to the fifth power minus 3 xi over rho cubed, like this. Then we have the second derivative of rho with respect to eta squared. This is 1 over rho minus eta squared over rho cubed. And from here we can also calculate, for example, d3 rho with respect to d xi d eta squared. And this is minus xi over rho cubed plus 3 eta squared over rho to the fourth power times xi over rho. And then we can also find d3 rho with respect to xi with respect to zeta squared. This is minus xi over rho cubed plus 3 zeta squared xi over rho to the fifth power. Then we also need other derivatives, like the second derivative with respect to xi squared of 1 over rho. This is the derivative with respect to xi of minus 1 over rho squared times xi over rho, which is minus 1 over rho squared, 1 over rho minus xi squared over rho cubed plus 2 over rho cubed times xi over rho squared, which is equal to minus 1 over rho cubed plus 3 xi squared over rho to the fifth power. And then we also have the third derivative with respect to xi cubed of 1 over rho, which is 3 over rho to the fourth power xi over rho plus 6 xi over rho to the fifth power minus 15 xi squared over rho to the sixth power times xi over rho, which is equal to 9 xi over rho to the fifth power minus 15 xi cubed over rho to the seventh power, like this. Then let's also write the second derivative with respect to eta squared. of 1 over rho. This is minus 1 over rho cubed plus 3 eta squared over rho to the 5th power. And you can easily find the expression from this one. And then we also need d cubed with respect to xi, with respect to eta squared of 1 over rho. And this is equal to 3 xi over rho to the 5th power minus 15 eta squared xi over rho to the 7th power. From here, we can also find the expression d cubed d xi d zeta squared of 1 over rho, which is equal to 3 xi over rho to the 5th power minus 15 zeta squared xi over rho to the 7th power. Now we can calculate the derivative of f with respect to xi. So if we calculate this, we will be able to substitute here in the expression for u. And we also have to remember that the sum of the constants a plus b plus c is 0. So let's substitute the derivatives that we have calculated. We have a times c prime times, here we have 3 xi cubed over rho to the 5th power minus xi over rho cubed minus 2 xi over rho cubed. I have simply substituted one of the derivatives, because if you check the expression for f here, you can see that in this first term we have this term here, but we also have to take the derivative of this term with respect to xi again, because we have df over dxi. So I have to substitute the expression for the third derivative of rho with respect to xi. So I have calculated somewhere here, and here it is. It's this expression. So as you can see, I have put 3 xi cubed over rho to the 5th power, and then I have rewritten the second term here by splitting it into two parts. So it's minus xi over rho cubed minus 2 xi over rho cubed, which is of course minus 3 xi over rho cubed, but it was convenient to rewrite it in this manner. And then similarly for the other terms, you have a b prime, and then here you have 3 xi over rho to the 5th power minus 15 xi cubed over rho to the 7th power plus 6 xi over rho to the 5th power. Then you get plus bc prime minus xi over rho cubed plus 3 eta squared xi over rho to the 5th power plus b prime 3 xi rho to the 5th minus 15 eta squared xi over rho to the 7th power plus, and then you have plus c prime minus xi over rho to the 3rd power plus 3 zeta squared xi over rho to the 5th power plus cb prime 3 xi over rho to the 5th power minus 15 zeta squared xi over rho to the 7th power. And we can simplify some of these terms. You can take this one, and also this one, because you can see that if you sum these terms, we can factor a times c prime plus b times c prime plus c times c prime, but we know that a plus b plus c is 0, so we can simplify those terms. We can cancel them. And then similarly for this one, and this one. And therefore we can write that expression like this. We have 3c prime xi over rho to the fifth power a xi squared plus b era squared plus c zeta squared minus 2a c prime xi over rho cubed minus 15 b prime xi over rho to the seventh power times a xi squared plus b era squared plus c zeta squared plus, here we have 6 a b prime xi over rho to the fifth power, and we can put some of these terms together. We can rearrange this in this manner. A xi squared plus b era squared plus c zeta squared, which multiplies 3 xi over rho to the fifth power. Here we have c prime minus 5b prime over rho squared. Then we have minus 2c prime a xi over rho cubed plus 6b prime a xi over rho to the fifth power. And therefore, we can find the expression for u. So we have u equal to a xi plus 2c xi over rho cubed plus a xi squared plus b era squared plus c zeta squared times 3 xi over rho to the fifth power times c prime minus 5b prime over rho squared minus 2c prime a xi over rho cubed plus 6b prime a xi over rho to the fifth power. And we can also rearrange the terms quite differently. We can rewrite that as a xi times 1 plus 2c prime over rho cubed minus 2c prime over rho cubed. So these terms will cancel, plus 6b prime over rho to the fifth power. This expression below here comes from the fact that I have put together this term here, because c is equal to c prime times a, so you can collect xi times a from these two. And then I have also collected a times xi from these two. And then we are left with a xi squared plus b era squared plus c zeta squared times 3 xi over rho to the fifth power times c prime minus 5 b prime over rho squared. And then we also have to impose the condition u of rho equal to r equal to 0. So when rho is equal to r, this must be equal to 0. And so the equation that we get is a times xi times 1 plus 6b prime over r to the fifth power plus a xi squared plus b era squared plus c zeta squared times 3 xi over r to the fifth power times c prime minus 5 b prime over r squared. This should be set equal to 0 for every xi, era, and zeta, such that the square root of xi squared plus era squared plus zeta squared is equal to rho. And the only possibility that we have is that this is equal to 0 here, and also this is equal to 0. because the expression cannot depend on xi, eta, and zeta, and that should be set equal to 0. So we get basically b prime equal to minus r to the fifth power over 6 from here, and from here we get c prime equal to 5b prime over r squared, which is equal to minus 5 over 6 r cubed. So the expression for u that we find is the following. U is equal to a xi minus a xi squared plus b eta squared plus c zeta squared times xi. Then here we have 5r cubed over 2 rho to the fifth power minus 5 r to the fifth power over 2 rho to the seventh power minus r to the fifth divided by rho to the fifth times a times xi. And now we can reason thanks to symmetry in order to find the expression for w and v. So we need to find w and v. So the second component is v. Let's write v. We can simply take a look at this expression and we will replace a times xi by b times eta. Then this part here does not need to be replaced because we have both xi, eta, and zeta. So there is some kind of symmetry there. We don't need to replace that. We have a xi squared plus b eta squared plus c zeta squared. We have to replace xi, so we will put eta here, which is something that can be obtained also by direct calculation. But we can avoid that just by thinking about symmetry. Then we have this term, which is exactly the same because it depends on rho, and rho is symmetrical with respect to xi, eta, and zeta. If you take a look at the expression of rho, so we have 5 rho cubed over 2 rho to the fifth minus 5 r to the fifth divided by rho to the seventh times 2 minus r to the fifth over rho to the fifth times b eta. So instead of a times xi, we will have b times eta. So this is the expression for v. And now we just have to guess the expression for w. It's quite easy to guess from these two. We have w equal to c times zeta minus a xi squared plus b eta squared plus c zeta squared times zeta times 5 r cubed over 2 rho to the fifth power minus 5 r to the fifth power over 2 rho to the seventh minus r to the fifth power over rho to the fifth times c times zeta. Just like this. So we have found the expressions for u, v, and w. We can also find the expression for pressure. Before concluding this video, we have pressure. Remember the expression. Pressure was equal to 2c times k times the second derivative with respect to xi of 1 over rho. It was this expression here. C is equal to c prime times a, remember that. And we found c prime earlier. C prime is equal to this constant. But remember that we found this expression in the case u prime not equal to 0, v prime equal to 0, and w prime equal to 0. So in order to find pressure, we have minus 5 over 3 r cubed times k, and then here we have a times d squared dxi squared of 1 over rho plus b d squared d eta squared 1 over rho plus c d squared d zeta squared of 1 over rho. So this is the expression for pressure, and one can also substitute the expressions for these derivatives. I'm not going to do it here, but it can be done. And it is also possible to check that k times the Laplacian of the velocity which is characterized by the three components u, v, w, is equal to minus the gradient of the pressure. You can check that this equation is satisfied indeed, and also that the divergence of the velocity is equal to 0. They are easy to check. They are just calculations. We will finish this lecture here, but we will continue next time because we still have to dig deeper and need to find, just like Einstein did in his investigation, the work supplied to a volume of fluid, which is also related to heat, because that work is converted to heat. And we'll do it starting next time.